Welcome to some notes on applications of linear equations. In this video we're going to use linear equations to solve problems and set up a formula and solve it for a single variable in the formula. Alright, so when we're solving word problems, we want to be able to read these problems carefully and come up with a variable, typically x, to represent an unknown quantity in the problem. Typically it's the thing that we know the least about in the problem. And if it's necessary, we're going to write any other expressions for other unknown quantities in the problem in terms of that same variable. So if there's more than one thing we don't know, then typically there's something we know the least about. That's going to be our x, or again any variable. And then the other things we will say, alright, well this is 2 times that, or this is 5 more than that, because of the way the problem is worded. So we'll be able to use the same variable for the other unknown quantities. Alright, then we're going to come up with an equation that describes how these unknown quantities are related, and then we're going to set up, and after we've set up, we're going to solve that equation. Alright, we want to check the solution like before. If we do that, we want to go back into the original wording of the problem before we actually did the math. Not necessarily what we came up with in step 3, but what the original problem that we came up with, the equation actually said. Okay, so I'll show you when we get in there what I mean by that last step. Alright, here's just some common phrases that typically mean addition, subtraction, multiplication, division. This is not an exhaustive list. You can add more to this in the blanks that are there. You can even go down here if as needed. But just know that typically these are the phrases that mean these 4 basic operations. Alright, so here's an example. So these are the 10 most popular college majors, with the median, which is kind of like not necessarily the average, but the middle number, 50th percentile basically, for starting salaries for people right out of college, what they make in that first job that they have out of college. Alright, so if something said this, the median starting salary of a business major exceeds that of a psych major by $8,000, and the median starting salary of an English major exceeds that of a psych major by $3,000. Alright, so in those 2 sentences, we are told how business majors compare to psych majors and how English majors compare to psych majors, but we know the least about the psych majors. So because of that, we're going to let X be the salary for the psych major. And then we're also going to do the second step, which says, now that we know what X is, how can we come up with the other unknown things, which are the business and English majors, and use X to describe those? Well, the business major exceeds, so that means it's more than, a psychology major by $8,000, and if you remember, more than means addition. Alright, so we're going to add to that X, that unknown amount. So we're going to say X plus 8, so 8,000, instead of writing 8,000, we'll just use 8 and just say that X is measured in thousands. Alright, and that's the business major. And then X plus 3 is the English major. Alright, now that's our declaration of our variables, and then we're going to use this right here is where our equation is going to be. Combined, which means we're going to add these 3 things up. The median starting salaries are $116,000. So again, we're just going to use these numbers, right, and leave off the thousands and just say X plus 8, X plus 3 are measured in thousands. Alright, now, after we've declared our variables, we're going to combine these 3 things to add up to the total of 116,000. So these 3 things added together, X plus 8 plus X plus 3, are all combining to equal 116,000. So that's going to be our equation that we use to solve to get x, and then eventually x plus 8 and x plus 3. Alright, so we've declared our variables x plus 8, x plus 3. Now we're writing an equation that models the conditions, which says combine, they get the 116, so we're adding them together. And then to solve the linear equation, we just take that original equation and simplify it. So there's 3 x's, so x plus x plus x is 3x. 8 and 3 is 11. Okay, these are pluses. We're not multiplying, so we don't have to distribute like we have to get rid of the parentheses. These parentheses are actually not needed. They're just there to show the 3 different quantities. This was the psych major, the business major, and the English major. They're not needed, so we can simply remove them when we're combining the like terms. Okay, now we've got an equation that has x's on one side, x's and constants here, and just constants on the other side. So the easiest thing to do to get rid of, or to get x's on one side and constants on the other, is to subtract 11. Alright, if I subtract 11, I will only have x's on the left and only numbers on the right. So that's going to be my next step, and getting closer to having x by itself. So we get 3x equals 105. 116 minus 11 is 105. And then finally, 3 times x equals 105. We don't want 3 times x. We just want x. So we're going to divide both sides by 3. And that will solve the equation. I don't mean that, meaning we'll get x by itself at that point. So dividing both sides by 3 gives us the solution that x is equal to 35. Okay, so since x is 35, that's the median starting salary in thousands, so 35,000 for a psychology major, and then we add 8, so 35 plus 8 is 43. That's the median starting salary of a business major, and then add 3 to 35, which is 38,000, which is the median starting salary for English majors. Okay, so it's important that we understand that these are in thousands, but that's the answer. Okay, make sure that you understand your units and what you just found. So we declared x to be psych x plus 8, x plus 3, so we're plugging that x back in where we saw x in all 3 of the original expressions that we started with to get the all 3 values. Alright, and check in the wording of the original problem. We just go back to the way the original thing was worded and see that everything works out, that these numbers are 8,000 and 3,000 bigger, and then when I combine them, the 3 numbers do add up to 116. Alright, so let's look at another example. So we got a texting plan. Plan A has a monthly fee of $20, a flat fee that you're going to pay no matter if you text nobody or if you text 100 people. You're still going to have to at least pay that $20. But you get charged also 5 cents per text with that plan. Alright, Plan B, they give you a lower monthly fee, but they charge you double for every text that you send. Okay, both plans have photo, video, text. How many text messages will the 2 plans be the same? So same thing, you're going to declare your variables. X is our number of text messages, which the 2 cost the same. That's the thing we're going to solve for. But we've got to come up with an equation that describes these 2 plans. All right. Now the key thing here, where's the X going to be? Where's the variable going to be? Typically with these charge per item, it's that sentence that has the per in there is where X is going to show up. So the 5 cents per text, the X is how many text messages. So this is going to be 0.05 times X. This is going to be 0.10 times X. And the $5 is on top of that per text charge. So we're going to add these fees to these expressions that have the charge per text. So there's going to be our equation, $20 plus 0.05 times X, and then $5 plus 0.10 times x. So again, where we see that per text, per call, per mile, if it's like renting a car, that's where we're going to see these x's pop into everything. Alright, if you were following that 5-step guideline, step 2, represent other unknown quantities in terms of x. There were no other unknown quantities. It's just how many minutes until they're equal, or how many ticks until they're equal. So there's nothing else that we're having to find here. So nothing to do with step 2. Step 3, come up with our equation. So our equation is what I was mentioning in the last one that we're going to do. $20 plus 0.05 times x. Where is that equal to? $5 is the base plan plus 10 cents per text. So 5 cents, 0.05, 10 cents, 0.10. So there's our equation that we're going to use. Alright, and then we're going to solve that equation. So how do I solve that? Well, I'm going to, I can't do any, there's nothing to combine on the left or right. This has got x's, this doesn't. This has an x, this doesn't. So there's nothing to simplify on each side. So we're already ready to group the like terms together. Move variables from one side, constants to the other. So the very first thing that we did here is we subtracted, and this should be 0.05. I apologize. So the first thing I did here is subtract 0.05x from both sides. Okay, and that got rid of it on the left. But on the right, 0.1x minus 0.05x is another 0.05x. Okay, so now I've got the variables together on the right side. I want to get the constants together on the left side. So I'm going to subtract that 5 away. Alright, 20 minus 5 is 15. So I've got this equation. 15 equals 0.05x. Alright, and then finally, I don't want anything with the x. So if there's a number being multiplied by x, I divide it away. So 0.05 divided by 0.05 is 1. So 1x is what I want. And then 15 divided by 0.05 is 300. And again, at that point, you're ready to go to your calculator to do that. So just type it on your calculator, and you'll see where that 300 comes from. So 300 is the number of minutes required for these two plans to be equal. Okay, now remember the original equation, the left hand and the right hand are the expressions that we started with. Alright, that was the $20 a month plus 5 cents per text. So if I start off with $20 and then I have to pay 5 cents 300 times, I have to pay $35. If I started off with $5 as a fee and 10 cents 300 times, because it's 300 text messages, again I have to pay $35. So they are equivalent when x is 300. So that shows that does check out. Alright, again we see that they're both equal to 35 when we use 300 minutes. Alright, another example, price reduction. So when we have percents, price reduction or percent increase, percent tax, all these different types of problems, these are, a lot of times, are set up the exact same way. You're going to let x be either the amount after the price reduction, let x be the new price, the new sales price, but a lot of times it depends on the wording of the problem. It could be what was the price before the reduction, which is what it's going to be here, and the percent could be, well, if it was like tax, what was the price before the tax was added. So it's all about the wording of the problem. But this one's asking us, what is the price before the reduction? Well, that's what we're going to let x be. What is the price of the camera before the reduction? Now, there are no other variables to set up here, just like the last problem. So there's nothing to do for step 2. But step 3, we have to be careful about how am I going to set this up. So if x is the price before the reduction, then we're going to subtract from x. We're taking the price before the reduction and we're reducing it by some amount. Okay, now what is the amount? It's 40% less. Now remember, when you have a percent in a problem, that percent can't stand alone. It has to be multiplied by something. So 40% as a decimal, 0.40 or just 0.4 would be fine. But 40% of what? Okay, a percent has to be multiplied by something. So it's 40% of the original price before we reduced it. So that's 40% of means multiply with these types of problems. X. 40% of the original price. The original price was X. Equals the new price. So equals 276. So there's our equation that we're going to use for step 3 when we set this thing up. So X minus 0.4X equals 276. So remember, percents can't stand alone. They have to be multiplied by something to be able to show up in an equation. All right, and then we're just going to solve. Now, you may be wondering, where does this come from? How do I go from here to here? Well, we have to remember there's this understood 1 in front of this. Sorry, it's 1x minus 0.4x. And all we're doing here is we're taking the 1 and we're subtracting the 0.4. And that's where that 0.6 is coming from. So 1 minus 0.4 is 0.6. All right, we're combining the like terms. All right, and then the last step with these, if we have a variable on one side, a constant on the other, we just divide away the number that's in front of the x. Okay, it's being multiplied. Inverse of multiplication is division. So we take the 276, we divide by the 0.6, and that's where that 460 is coming from. So that means the camera was $460 before we reduced it. So how do you check it? Well, you take $460, you figure out what 40% of that is, and then you take that 460 and you subtract the 184, and you get 276. So it does check out. All right, the last type of thing you're going to do in this section is solve a known formula for another variable in that formula. So this really tests your ability to do the problems that we've just been doing, because now we are going to have more than one variable typically. And in this case, we have several variables. So we can't actually get a solution, meaning that we're not going to have like L equals 5 or L equals 1/3. We just get L equals, and then there's going to be P's and W's and numbers on the other side. So it's a little bit different. We're doing the exact same thing, it's just we can't simplify each step and get a number at each step along the way. So we have to be really sound with the process, meaning we have to really understand what's going on. Alright, so the first thing we want to do, we want to solve for L. I just highlight it here. This is what I'm wanting to get by itself, meaning I want everything else on the other side. So the first thing we've got to do is kind of like we got to chisel away to it. Think of this as like a diamond inside a piece of coal. So to get to that diamond, we want to break off the things that's furthest away and kind of chisel our way into it until this is the only thing left. So the first thing we're going to do is get rid of that 2W that's sitting out there beside of it. So we're going to subtract 2W from both sides, and that way we're a little bit closer to having just the L by itself. Okay, we're not quite there because we have two L's instead of just a single L, but at least we don't have the W over there with the L anymore. Okay, now this is what I was talking about before. We don't know what P and W are. They're just letters. They're just variables where numbers would go. So we can't combine anything. We can't get a number. We just have to leave it that way. Okay, and what would we do though if this was a number? If this was 2L equals 6, we would divide both sides by 2. Well, we're going to do the same thing. We're going to divide both sides by 2, but there's nothing we can do on the left-hand side. It's just show that we're dividing the left-hand side by 2, but we can't simplify. There's nothing else we can do. So we're actually done at this point. We have L isolated, meaning there's nothing over there with the L, but the left-hand side is just an expression, and that's the best we can do when we solve a formula for a variable. We can't solve and get a number answer. We just have to get an expression. So there is some things you can do to check if this is right, It's not like checking with the last thing, but it's similar. Pick some numbers for P is by itself, so just pick some numbers for L and W. So I'm going to say, like, let's say L is 1 and W is 2. Just picking some numbers at random. So if L is 1 and W is 2, this would be 2 times 1 plus 2 times 2. Right, and 2 times 1 is 2 plus 2 times 2 is 4, and 2 plus 4 equals 6, which is P. So P is equal to 6. Now, in the other expression that I come up with at the end, if I replace everything that's in this expression we came up with in the end with what we just came up with here, I mean P being 6, L and W being 2, we should also get an equal expression, or a true expression. So here P is 6, so 6 minus 2 times W. 2 times W was 2, divided by 2 equals L, and L, we're saying let that equal 1, and see if you end up with a true expression. Well, 2 times 2, remember you got to do order of operations, so 2 times 2 is 4, so 6 minus 4 over 2, that's 6 minus 4 is 2, and 2 divided by 2 is 1. So it does check out, meaning that our expression at the end is equivalent to what we started with, because we rearranged, we plugged in numbers into this expression, we rearranged it, all the numbers when they plug in give us a true expression also. Alright, now that's not 100% foolproof, but that is just a quick, dirty way to kind of check to see if you've done it correctly. You just plug in some numbers in your original expression, and then plug in those same numbers into your final expression, and see if you get a true statement in both. Okay, now notice up here I plugged in for L and W and figured out what P would have to be, and then plug those numbers in down at the bottom. Okay, it's not a requirement, it's just a way that you can check formulas when there aren't any numbers. Okay, up here, the 5-step process we've been talking about where we check, we were getting a number at the end, so we could plug it back into the original and show that they're equal. Well, here we're not getting numbers, we're getting expressions. So we can't just plug in to see that they're equal, we have to kind of manipulate it a little bit ourselves to check. Alright, now here's another one. If I have this formula and I want to solve it for P, so same thing, this is what I'm trying to isolate. So what am I going to do? I'm going to make myself make my way from outside in. So I'm going to get rid of the D first. So this D and this D are gone, leaving with just the P. Right, and then I want just P. I don't want the M with it. So I'm going to divide both sides by M. And M divided by M is 1, so I'm just left with P by itself. But again, there's not a single number in this. So again, I can't simplify, I can't get a number. I just have to write an expression of what I would have gotten. All of this on the left is being subtracted, so that all has to be in the numerator when I divide both sides by M. Notice the fraction bar here extends all the way below the T and the D. And there's our solution. Again, that's as far as we can take this thing. Alright, again, the dirty way to check this, the T is isolated, so pick something for these other three. So I'm going to say D is 1, I'm going to say P is 2, and I'm going to say M is 3. Again, just to have something to check it. So again, order of operations, 2 times 3 is 6. So that's 1 plus 6. 1 plus 6 is 7. So that means T is equal to 7. Okay, now back in this expression down here, I'm going to replace T with 7. I'm going to replace D with 1, P with 2, and M with 3, and see if this is true down here. If it is, then again, I've isolated P correctly. So T minus D would be 7 minus 1 divided by M. M is 3. And we want to know, is that equal to P, which is 2. And again, we see it is. 7 minus 1 is 6. 6 divided by 3 is 2. So, not a requirement by any means, but just a easy way to check that you've done these variables isolated by themselves correctly.